Hi, 12. This is the second video. This is going to be talking through the tangents and normals section of the revision sheet. So let's get onto the document. Here we go. So pen is now working. Find an equation of a tangent, that curve at the point where x equal to 2. So tangents, normals, what we need to start by doing is differentiating. Of course, differentiating tells us the gradient function. It tells us the gradient at every single point of the curve, and it should qualify by saying it tells us the gradient of the tangent at every point on the curve. So we differentiate. The function itself is quite straightforward. Differentiate x cubed 3x squared. And then I've got 2 multiplied by the derivative of x squared, which is 2x. Differentiate 1, 0. So let's just simplify that. 3x squared minus 4x. So that tells us the gradient of the tangent at every point on the curve. So we know that when x is equal to 2, the gradient of the tangent is equal to, so we're substituting 2 into dy dx. So 3 times by 2 squared minus 4 multiplied by 2. That gets me 3 times 4, 12. 12 minus 8, 4. So I know that the gradient of the tangent is equal to 4. So we've got the gradient. We know that we're going to be using the equation of a straight line, which is y minus y1 is equal to m, x minus x1. And we've already worked out that m, the gradient just above, is 4. I know that x is equal to 2. Of course, what we need to do is we need to find y. To find y, I take that x is equal to 2 and I just substitute it into the curve. So I know that when x equals 2, y is equal to 2 cubed minus 2 times 2 squared plus 1. And that gets me 8 minus 8 plus 1. That is equal to 1. So go back to y minus y1. I'm going to have y minus y1, which I've just worked out above, which is 1, is equal to m, which is 4, x minus x1, which is 2. And then simplify that, multiply out the brackets on the right. I've got 4x minus 8. So y is 4x minus 7. Okay, so hopefully not too troublesome. Remembering using that equation of the line. You can, of course, use y equals mx plus c, but that one just is a little bit more direct. Okay, so next up, what have we got? Okay, a normal. So a curve has equation y equals x squared plus x. Find the equation to the normal to the curve. So the key point here is that whenever you have a curve, so there is my curve, we have got a tangent. The tangent there is the one that just touches the curve. The normal, this line here, cuts it at right angles. So the crucial fact is that these two are perpendicular. So whatever the gradient of our tangent is, the gradient of the normal is perpendicular. So the product of the gradients is -1, but you might think of it as being the negative reciprocal. Whichever we do, we definitely need to start off by differentiating. So dy dx, again, the function itself is very straightforward. X squared, differentiate 2x, differentiate x, we'll just get 1. So I know that the gradient of the tangent, so always start by writing out the gradient of the tangent. Don't take any shortcuts and go straight for normal. It's really easy to get confused. Gradient of tangent at x equals 2. is equal to 2 times 2 plus 1, which is equal to 5. So hence I know that the gradient of the normal is the negative reciprocal, so it's minus 1/5. And then, as I did before, I'm going to be using y minus y1 is equal to mx minus x1, but to do that, I first need to work out the y value. So when x equals 2, y is, so the curve x squared plus x, so remember back up to there, and my x value is 2, so I am working out 2 squared plus 2, which is 6. So finally, using my y minus y1, which I've just worked out, 6 is equal to negative 1/5 x minus x1, and x is 2. We have got, we've got, I need a bit more room. Expanding those brackets, y minus 6 is minus 1/5, and in fact, expanding those brackets, what it would be sensible to do first, because I'm thinking about how the question's been asked. It wants in that form a, b, and c integers, so we don't want any fractions. So rather than expanding the brackets, if I multiply by 5 first, or multiplying by negative 5, that's, sorry, don't know why it's gone to fat pen. That gets me rid of that negative 1/5 there, and I've just got an x minus 2 there. I've written minus 5, of course, I've missed off a y. So just to repeat what I've done there again, I could have expanded the brackets, but if I multiply by negative 5, it gets rid of that. I have a negative 5y, I'd have a plus 30, and then it leaves me with what I've got there. And then just simplify that. It wanted everything together on the left-hand side. So I'm going to leave the 5y where it is. The x is going to be negative, and then I've got 30 minus 2. So minus x minus 5y plus 28 is 0. And that's not right, is it? Because it was a negative 2 here, and that means it's going to be a plus 2 when I pop it over there. And so this is going to be a plus 32. Well done for all of you who didn't make that mistake. Oh, and I'm just a little bit worried about that x as well now. Nope, that's all fine, isn't it? That's good. Yes, sorry, I was worried about those signs. Okay, so the last of the tangents and normals. Now, this looks a little bit nasty. So what we've got here is the big fraction there. The rest of it seems exactly the same, doesn't it, as previous questions? So work out the equation of the tangent, x is 1, give your answer in that form. So the main problem with that question is dealing with that fraction. Similar to one of the questions, was it question 3, question 4 earlier on? We know that we cannot deal with those brackets. So the first thing to do would be to expand the brackets on the top. So I've x squared times by x, that gets me x cubed. X squared times by 3 is negative x squared. I've got 4 times by x, 4x, and 4 times by negative 3, minus 12 over 2x. And now there's a couple of things that you could do. You could either think of that as being 2x to the power of -1 multiplied by each of those terms on the bottom. That is a little bit awkward though, because you've then got to deal with that, or you've got to think about what that 2 to the power of -1 is. That 2 to the power of -1 is actually half. The way that I think makes it plainer what's going on, just write it as 4 individual terms. Then you can think about the divisions separately. Writing it like that, of course, is fine because we've just got a single term on that denominator. Okay, if we didn't have a single term on the denominator, we couldn't do this. Think about how, if you were given that expression there and get back up to the previous expression, there's a common denominator, so you can just combine by adding, subtracting the terms on the numerators. So it's having a common denominator and actually separating them into their individual fractions. And now this is very nice because we can just use our rules of indices. I've got x cubed divided by x to the power of 1, or just, you know, some of you would think of that as cancelling. So that's x squared over 2. There I've got x squared over x to the power of 1. That just gets me an x to the power of 1 on the top here. An x to the power of 1 and an x to the power of 1 cancel, and I'm left with 4 over 2, which is just 2. Here, that 12 over 2 gets me 6. So that last one is 6 over x. And before I differentiate, I certainly need to kind of rewrite that one to have it as a power of x. And in fact, let's just write all of the previous terms as a fraction times by the power of x. So I'll have a half x squared. This will be minus 3 over 2x plus 2 minus 6 x to the minus 1. And now I can differentiate. So if I differentiate that, I'll have a half times by 2. So that's just going to get me x. Here I am differentiating minus 3 over 2x. The x vanishes. I'm just left with 3 over 2. Differentiate the 2 and that just goes. It's just a constant. Be a little bit careful about this last one here because the negatives, I'm going to write down the minus 6 and then going to differentiate the x to the power of minus 1, bring the power down, reduce the power by 1. And then tidy that up. It's a little bit confusing because, oh, this is all one term, isn't it? So that there is my last term. So minus 6 multiplied by -1, so it's going to be plus 6x to the minus 2, and you may or may not. I prefer to write that like that. Okay, so now we've got that, we can do our tangent finding. So I know that that is the gradient. A function tells me the gradient at every point on the curve, the gradient of the tangent at every point of the curve. So the gradient at x equals -1 is going to be -1 minus 3 over 2 plus 6 over -1 squared. Obviously be careful about the negatives here. That gets me -1 minus 3 over 2. So that's minus 5 over 2 plus 6. 6 over -1 squared is just 6. So that's 12. That's going to be 7 over 2. We then need to find the y value. So I know that the x value is -1. So we also know that when x is -1, y is, so we need to go back to this fraction here. So I'm substituting -1 into the right-hand side. You can, of course, substitute it into your expanded version or even into your kind of rewritten version like that. But just in case, you know, you've made any errors, you might have made things more complicated for yourself. I would always advise you to go back to this first one there. So I've got x squared plus 4. That is going to be -1 squared plus 4 multiplied by -1 minus 3. And on the denominator, 2 times x, so 2 times by -1. -1 squared plus 4, -1 squared is +1, so that's going to be 5. That second bracket will be -4, and on the denominator, I've got -2. So that's -20 over -2, that's +10. So these are all the bits I need. I'm going to use y minus y1 is equal to m, x minus x1 y minus y1, which is this 10, is equal to m, which is the 7 over 2, because it's a tangent, we weren't finding a normal. So 7 over 2, x minus an x1, of course, is that -1. So we're going to have a double negative in there. I think it wanted, yeah, a, b, and c are integers again. So I'm going to multiply by 2, just get rid of that half at once. So it'll be 2y minus 20 is equal to 7 lots of x plus 1. 2y minus 20 is 7x plus 7. Put everything onto the left-hand side. Minus 7x plus 2y, and it'll be -20 minus 7. -27 is equal to 0. Okay, so that's the end of this video. Let's stop presenting, stop recording, see you for the next one.